Welcome back to this channel once again. So let's continue our previous tutorial which we created in last video. So let me open my Simapro first. Yes, here we had created one project, that is building tutorial. It is already here. If you have saved it properly, it must be here. Now let me open this project and let's see which type of progress we had made in last video. So basically we had created a few sub-assembly in last video. Now we are going to update the remaining inventory. Last time we updated up to wall. So let's create another sub-assembly. This flooring. Let's see which type of material we may need for flooring. And you are going to search this exact category of material with the help of keywords. So let's try to search with the keywords. Oh, nothing is here. Let's try it again. If not, then we should go for manual screening. Nothing is here. So we should search manually. To search manually, we must have a fair idea or little bit idea which category our material belongs to. Here in this case, we are talking about steel. So as per my knowledge, it should belong to metal. So let's click metal and see which type of subcategory are within metal. There are several categories. I think the best one is ferro. So we should try to search within ferro. That may give us the exact category of material which we are looking for. Okay, let's see. There are several. So let's select one suitable one. For me, I can select any suitable category. But in the meantime, if you have a time, then you should explore by your own and try to find the exact, exact inventory which may be closer to, your requirement. For me, I'm going to select this one. Let's see how much quantity we may need. Saved it. Let's check where we need another inventory for this sub-assembly or not. I don't think so. I think this is the only item which I had included in inventory. Now we should create the remaining sub-assembly. So we are going to create another new sub-assembly, that is flooring. Let's see which type of material we may require for flooring. Let's say tiles, ceramic tiles. So let's try to search this item within our database. Oh, there are several options. So which option maybe, I mean, more closer to our project? Let's select any one. For me, I'm going to select randomly, but you should explore by your own, as I already told. Oh, again, one small issue here. The unit is meter square. We have to convert this meter square into kg, because if you will not convert, then in later phase when we will be modeling for a disposal scenario, then we may have to face some issue, because in product stage we should model in kilogram, or we should model in mass unit only. So let me try to convert this into kg. So let's assume we may need for 5, let's say 5 number of tiles to cover 1 meter square, and let's assume each tile has a 5 kg weight. That means 5 into 5 at 25. So let's try to update it accordingly. We can directly put it here 25, or even you can use an arithmetic expression, and this thing is valid here in Simapro. So even in future also, if you have to insert too many, I mean, arithmetic terms, then you can use an arithmetic expression as I used here. Several items remaining, so we'll try to update one by one. Let me try to update as quick as I can. We're creating another sub-assembly, finishes. Let's see which type of material we need. Cement, again cement and sand. We have already selected cement and sand, but for different sub-assembly. I can't remember the exact category or the exact material which we had selected for the earlier for wall and structure. But anyway, it doesn't make much difference here. We'll select any suitable category of cement and sand. So 5 kg. Let's try to find the sand category. Oh, there are several options we have. And kindly pay attention here that whatever the material or process we have selected only system based, not unit based. And there is a reason behind it, which we'll discuss in coming videos. Water tap. Ten kg. Finish. Now we are going to create another sub-assembly, that is windows and doors. Let me see which type of material we may need for this. It's a PVC, sorry, it's a aluminum or wood. We should go for wood, or even you can go for aluminum as well. No issue. So we need wood and glass, and let me update it quickly. Let's search the suitable category of glass. Just don't waste our time in searching a suitable category. Let me update with any category of glass here. Okay. Now I'm going to insert some comment. That comment may be very useful, especially during analysis phase. When we try to analyze anything, then we should see which component has contributed which type of impact or how much impact, and then you can easily know which component has how much contribution in environmental impact. For this also we have to update comment, although it is not mandatory. I selected wood randomly anyway, just for reference. So we almost finished all the inventory which may require for during construction phase. Okay, sorry, plumbing and electrical, that thing is remaining. So we are going to create another sub-assembly, that is plumbing and electrical. We need a PVC pipe, copper. Only one item is available. Let's try to search with some broader keywords. So let's take two keywords, and then nothing is here again. Or okay, so let's select any category of PVC. Forward. I think it's okay. I think that this is. I think we have updated all the inventory which may require during construction phase. Now we should think about some process which we have not updated, because during life cycle, especially in life cycle analysis, we have to consider each and every activity which may be expected during the life cycle of a building. So here we have updated all the inventory, but we have not updated how we will transport this inventory up to our site. For example, we have to transport bricks, cements from market up to your site, and for these activities, maybe truck or trolley, I don't know which type of means, but any category of means we have to use, and we should consider it properly here in life cycle analysis. That means total embodied emission, environmental impact during transportation, construction, such as mixing aggregates. Sometimes we have to use some mixer machine as well, and everything should be considered here. So let's try to update one more. Here I have clicked in process, not in material and assembly. So first I am going to update excavation. This is the normal activity during construction. So I have selected any suitable category. Let's say we have to excavate 1 meter cube volume for this functional unit, and during process it is not mandatory that things should be in kg only. Here any unit can be accepted. So for transportation purpose we used freight lorry, and then now we have to convert in ton kilometer. So as you can see here, I have estimated 0.355 ton total, weight of the total inventory, including sand, brick, cement, etc. So you can multiply this, and let's assume the distance between the market, the average distance between market and your site is 25 kilometer. So we updated this transport thing also. You can see it works here. So you can use arithmetic expression instead of inserting, or instead of doing arithmetic calculation by your own. So we updated excavation, we updated the environmental impact associated during transportation. Now we are going to update electricity, which may require during this processing. We have to operate some mixer machine and grinding machine. I don't know, some water pump. So we almost done here. Now we are going to create a super assembly, you can say, and that assembly will be covering all kind of expected environmental burden associated during construction phase. So we'll update, we are going to create that super assembly. Just I named it a super assembly. It's not as such a super assembly, but just for the sake of our reference. So it will provide us the total environmental burden associated during construction phase. We'll cover each and every item, every category, activity which can be expected during constructed phase, or which we have created for construction phase here in as a sub assembly in our database. So we are going to create a super assembly here. Let's try to update one by one. Finishes, flooring, wall. structure 1 1 divided by 1. Okay, perfect. So we updated all each and every sub assembly which we have created for construction phase. Oh, I think we forgot something. We forgot. Forgot yeah, that construction phase process energy transport and that water energy emission, sorry, environmental burden associated during transportation. We had not included. So let's update it. Now it's okay. Now it seems perfect. So this super assembly gives us the total environmental burden associated during construction phase. Now, now we should update another section here, that is a life cycle section. So in life cycle, we have assumed that the life period of a building is 50 years. So we should consider each and every activity, energy consumption scenario, activity or material or whatever can be expected during the life period of and here I have considered construction phase total. The reason behind the construction phase total assembly, it is a super assembly which has covered all the which covered all the potential environmental burden associated with the construction phase. And during process, we should consider each and every activity which may be expected during the life cycle period of the building. Here we have assumed 50 years life cycle period, and for the reference purpose only, we have considered two only energy consumption scenario. That is, the first one is for lighting, and second one for refrigerator. And I have calculated it in a very simple way. So, for example, we have a 4 tube light. Then we should multiply 4 tube light multiplied by days and multiplied by hours. And we assume that's 14 hours. Sorry, that light is operated 14 hours a day. Similarly, have analyzed electricity for the refrigerator purpose. So don't forget to mention here comment. It's may be very useful during analysis phase. So once we updated this thing, that means we have updated each and every expected environmental burden during the life cycle phase of the building. Now let's analyze. So I have already a little bit idea how to analyze, because I already explained in the last video. So select a method. If you not select method, you will not get anything as outcome. Or forget about just ignore this sorts of warning here. This is a material network. You can see it consists of a construction phase as well as the operation phase. This is the total environmental burden associated with the full life cycle period of the building. That is in yellow color. And you can optimize, you can customize it several ways. I'm not interested in these of here. Here these are the impact category, you can say. And again, let's again calculate and let's compare. Now it's better to compare. I think we should compare how much environmental burden is associated during construction phase and operation phase. So we are going to just compare. Let's see how to compare two scenarios. We have considered total impact during so we'll be comparing how much is the total impact is environmental impact, and we'll compare this with the total environmental impact associated with the construction phase. So let's see. So you should update it accordingly, construction phase total and then life cycle. I think it's better to select life cycle. Yeah. So the second one is the total environmental impact, and the first one is the only impact associated during construction phase. So we'll discuss in detail how to read this type of outcome in coming videos. So for today I think it's more than sufficient. Again, We can compare. Thank you very much for being here. And next video will cover the remaining things.